Hi everybody, today we will start with another exercise in the subject of the nervous system and concerning especially the synapse, the function of the synapse. In this exercise we will solve an exercise of the session 2018, the first session, exercise number 3. If you want to review the answer sheet in your books, in your guides, you can read carefully the given before you start solving the parts. This exercise includes only 3 parts. For the first part, after you read the given, show that the paralysis of this animal is due to dysfunctioning of the synapse. In this part, we will talk about the common mistakes made by the students during the execution of the part 1, and that we noticed when we corrected in the official exams. The first problem that we noticed is that few students take care or took care about experiment 1. When the students tried to answer this question, this part, they thought that they have to analyze only the table. But the part 1 show that the paralysis of this animal is due to a dysfunctioning of the synapse. When you say this is the nerve and this is the muscle, and the synapse is where the muscle is connected to the nerve or to the neuron. A paralysis in the animal prevents it from making contraction of the muscle. This paralysis can be due to either a problem in the nerve or a problem in the muscle itself, or a problem where in the synapse. If we want to prove that the problem is in the synapse, and show that means prove. Prove means make a logical analysis that make us sure that the problem is within the synapse. How can we prove that the problem is in the synapse? We have 2 possible procedures. The first is to make a study concerning the synapse to show that there is a problem in it. The first is denying the presence of a dysfunction in the muscle, denying the presence of a dysfunction in the nerve. So if there are no dysfunctions in the nerve or the neuron and in the muscle, so we are sure that the problem is in the synapse. And that is what we can do in this given, since we have no ideas in this given about the synapse itself. We have ideas about either the muscle itself in this part or the neuron and its connection to the muscle in this part. And that's we are going to do. In the experiment 1, effective stimulations are directly applied on the muscle M. Muscular contraction is observed in both cases. What does it mean? That if we make a stimulation on the muscle, in both animals, we obtain a contraction. What does it mean? A direct stimulation of the muscle is able to make contraction in it without any intervention of the nerve. and that's we have to uh, be conscious about it. The muscle can be contracted by direct stimulation, and that's what the experiment says. The muscle is contracted in both cases. What does it mean? We can say it means, and we have to give meaning in these experiments, since what we are asking you to prove is given. So you can't only that, and this is what the most of students make analysis of both, and then you say there is a dysfunction. This is not allowed. That the answer that is logic in this case, that you have to prove for us in this case that the muscle is not dysfunctioning. The muscle doesn't have any dysfunctioning. And this is what you have to say as a meaning of the first experiment. You deny the presence of dysfunction in the muscle in the paralyzed animal. In the second case, in the second experiment, effective stimulations are applied on motor neuron N. So now the stimulation is done where? On the neuron. And the results are given. You have in the normal animal a nerve message in the motor neuron. So there is here a nerve message. So the neuron is transmitting messages normally. And this is also the case of where of the motor neuron of the paralyzed animal. This means that, and you have to say the meaning in the logical analysis, the logical reasoning. This means that both animals have no problems in the neurons. The neurons can transmit messages, and this is important. And it is important to say it after you compare the paralyzed animal to the control one, which is the normal. You can't only observe the paralyzed animal and take meanings about it. But in the normal animal, you observe that the nerve message leads to contraction, while in the paralyzed animal, the nerve message leads to no contraction. What does it mean? Here also the meaning is very important. It is important that you say the nerve message is transmitted from the neuron to the muscle in the normal animal, but it is not transmitted from the neuron to the muscle in the paralyzed animal. And this is what that makes you sure about a problem where in the synapse itself, and not neither in the neuron nor in the muscle. And this is the answer for this question. The most common mistakes are that students didn't make any meanings. They thought that they can analyze only the experiments and they can say for us, look at me, I'm doing well, I'm concluding that there is a dysfunctioning of the synapse, but this idea is given. It is not from your ideas, it's not from your mind. This is given in the question. So what is your intervention? Your intervention is to give meaning for the first experiment, meaning for the first result in the table, and meaning for the second result in the table. That makes you sure that the dysfunction of the synapse in the paralyzed animal is the cause of this paralysis. So let's go now to the next part of the question of the exercise. Part 2, you have to read carefully the given. Part 2 says that determine, after studying the results of each of the experiments 3 and 4, the two rejected hypotheses. What are the two experiments? Experiment 3 indicates that there is an analysis of the content of the synaptic vesicles of the neuromuscular synapse of the paralyzed animal that reveals the presence of acetylcholine similar to that of the normal animal. You can notice that we are always comparing an experimental case to a control case. In this case, the analysis shows the presence of acetylcholine. So, one of the given hypotheses is, states that a deficiency in the production of acetylcholine is the cause of this paralysis. But we noticed the presence of acetylcholine, and this is what rejects the hypothesis. It's very simple, but you have to be clear in your answer. For experiment 4, the contraction of muscle M is obtained in both animals after we inject the acetylcholine in the synapse, in the synaptic cleft. What does it mean? It means that in the synapse, we injected acetylcholine here, and we observe a contraction in the muscle. So acetylcholine is able to act to cause the contraction. It means that it is able to bind on the receptor of the postsynaptic membrane, so it has receptors. One of the hypotheses indicates that the paralysis is caused by non-functional receptors of acetylcholine. And this idea contradicts the given. What you have to say in the answer? You have to say that when the acetylcholine is injected, we observe a contraction of the muscle. This means, and this meaning is always missed by the students, this means that acetylcholine is able to bind on the postsynaptic membrane receptors to cause contraction. And so acetylcholine has its receptors functional on the postsynaptic membrane. That contradicts the hypothesis 2. This is the answer for part 2, and it is very simple also. For the third part, this is the third part, and you have to read also the experiment, and I will explain the answer. Specify the cause of muscle paralysis in the animal. After making this experiment, we are able now to identify, to specify the cause of the paralysis. Since you can observe that radioactive choline is injected, this radioactive choline leads to presence of acetylcholine, leads to the synthesis of acetylcholine that will be radioactive. Radioactivity appears in the form of black spots. So everywhere you find black spots in the results, you can speak about acetylcholine. In this case, in the normal case, acetylcholine can be observed as black spots. You can say in the answer, black spots are observed in the synaptic cleft, and a black postsynaptic membrane is observed. In case of normal animal, that means that acetylcholine is released and is bound on the postsynaptic membrane. You have to use meanings. Without meanings, we are not able to identify your logic analysis, your logic reasoning. And with comparison, some of the students talked only about the animal that is paralyzed, but without comparison, you can't be sure that this is an abnormal state. How can you say that this is an abnormal state without comparing it with the normal? In the paralyzed animal, we observe black spots inside the presynaptic site. No black spots in the membrane, in the synaptic cleft, and no black spots on the postsynaptic membrane, it means that acetylcholine is not released in the synaptic cleft and can't bind on the postsynaptic membrane. Why? Because of it is not released. I don't mean that it can't bind because it doesn't have receptors, since we rejected this hypothesis before. Now, acetylcholine is not released. So because of acetylcholine is not released in the paralyzed animal and it is released in the normal animal, so the cause of the paralysis is the dysfunction in the exocytosis of acetylcholine from the presynaptic side of the synapse, and this is the cause of the paralysis. That is also one of the hypotheses that are made before the part 2 of this exercise. Thank you very much.